All right, guys, we have a little example here of a problem where we're writing the standard form of a parabola, but we're given some kind of different things we have going on. So they actually gave us the focus that the parabola opens down and that it contains the point -3, 1. So I'm going to actually draw these in. I think it's helpful to visualize. I didn't put a graph on the worksheet, but I put one on here. So I'm going to draw a focus at 1, 4. We know it opens down, so we're picturing a parabola right, kind of like this, and actually we have a point on it, so I'll draw it a little more accurate after that. Contains the point -3, 1. So we know that's a point on a parabola. And like we said before, it opens down. Now, actually, given this, we know the axis of symmetry is over the focus, so we actually have 2 points. We've got this one, -3, 1, and that's 1, 2, 3, 4. 2, 3, 4. We've got another point over here at 5, 1, if we think about that. So my parabola maybe looks something like this, but we're not quite sure where the vertex is right now. So there's a couple ways we can do this one. And I'm going to go, maybe I'll do both examples on here. But one way we can do this is we know that for any point on the parabola, it's going to be the same distance from the focus as it is to the directrix. So if I find this distance that I drew in green here, then we know where the directrix is, and then we can find our vertex. So I'm going to find that distance I drew in green, and this is what I'm doing. So I'm finding distance from the point to the focus. Now I'm going to use Pythagorean theorem instead of distance formula, so I know that this guy is 1, 2, 3, 4 units here, 3 units here, so it's 5 units away. So this means, since our definition of the parabola, every point's equidistant from the focus and the directrix, at this point, -3, 1 is 5 units from the directrix. So I'm going to count 1, 2, 3, 4, 5. And that's going to be my directrix. So I'm going to draw that line in there. And I need to do some erasing because my parabola is pretty messy right now. So I'm going to erase all those little dotted lines I had there. Take some other stuff with me. Going through. All right, just clean this up in general over here. All right, we had that guy was 5 units. That guy's 5 units. And now we can find where our vertex is. So since our vertex is halfway between the directrix and the focus, are 2 units apart, my vertex is going to be right there at, looks like 1, 5. And then we can write our equation. So this is a parabola that opens down. So it's going to be an x squared parabola. And we know the distance from the focus to the vertex, the focus to the vertex is 1, but since it opens down, we could throw that negative in there. So -1. So that means that my coefficient is going to be -4 for 4p. So that would be the equation of this parabola, and that method will work for any problem like this. Now we could go a different route with this if we wanted to. I think it's a little bit trickier, but I'm going to write it over here, and it's kind of more of an algebraic method. So I'm just going to write down kind of everything I know from the start here. So I'll call this method 2. So since they tell us that the parabola opens down, we know that it's going to be this standard form, at least to start. And then there are a couple things that we can fill in. Since they gave us the focus is at 1, 4, we do know something about the vertex, right? The focus has to be in line with the vertex. So we know that the x coordinate of the vertex is also going to be 1. So I'm going to start kind of filling in this equation down here. I'll put blanks in for now. So 4p would go here, y minus k x minus, we know that the x coordinate is going to be 1 for our vertex. So at least I have that to start off. All right. Now, if you think about parabolas kind of in general, I'm just going to draw a general parabola over here. If the vertex is hk, then the focus, if it's vertical, is going to be hk plus p. So for our vertex, right, we need, usually this guy is hk. And this guy, they gave us 4, is k plus p. Well, here's kind of our interesting part. We can figure out k. I'm going to write it over here. We have 4 equals k plus p. So k has got to equal 4 minus p. So I can substitute that in, just so we have less variables to go with, right? Or you could think about, right, if we have the vertex and it's opening down, we would go down p units to get to the focus. Kind of another way to think about that, but this is the trickiest part to this method. So 4 minus p is going to be our k, which is going to go here, 4 minus p. Sneaking that in. We don't know p, so I'm going to put that out here. Now, luckily, they also gave us a point on the parabola, which was -3, 1. So we can use that as x and y. So a little bit crazier over here solving this method. That's why I like that first one where we're really using the definition of a parabola, but this will get us there too. So now I'm going to simplify everything here. So we'll get a -3 right here, -3 plus 4. Did I switch my x and y? This guy should be our x. I did switch my x and y. Let's change that. So x should be here, that's -3. Y should be here, that's 1. Now, 1 minus 4 is -3. So I'm doing okay now. Fix that mistake. Sorry about that. Hopefully you guys are screaming at me. And then this will be a positive p once we distribute that negative. Over here we get -3 minus 1 squared, so that's 16. And then I'm actually going to divide the 4. And, oh my gosh, I'm making all kinds of errors. Square this side over here. So here we'll get p squared minus 3p. No, I was doing okay. Just multiply this through. I'll get p squared minus 3p equals 4. Now I just got a factor. Sorry, again, a little bit crazy, but hopefully you guys were just going through after you saw our setup there. So we get 2 possible answers for this one. P is -1 and 4. And since the problem told us that the parabola opens down, we have to choose that negative option and sub it back into our equation, which would give us that original one. All right, guys, so that's an example of one of our problems with parabolas. You guys can try out the other examples and let me know, as always, if you need help.